One of humanity's biggest worries of the future is the uprising of robots. Will artificial intelligence someday rise against us, or is that fear put in us thanks to Hollywood? Even Elon Musk seems afraid of AI taking over the world. He once wrote in a tweet, "If you're not concerned about AI safety, you should be. Vastly more risk than North Korea." The real question lies in the justification of his fear. Is there any cause for concern? Today, we're going to be talking about the strides that have been taken in the development of AI. We're also going to mention the fears surrounding AI. After all, if one of the smartest people in the world is worried, then we shouldn't fold our hands either. Before we go any further, why don't you click on that like button and subscribe to the channel for more videos like this. With the integration of artificial intelligence into the businesses, technological professionals are now looking into a new frontier into AI innovation. This is what is known as the area of meta-learning. Meta-learning is what is known as learning to learn. Human beings have the wonderful ability to learn from any situation we find ourselves in. We adapt to the situation we find ourselves in and learn to learn. We figure out how to learn. This kind of learning flexibility is sought after in the intelligence world and is also known as artificial general intelligence. This means that AI needs to have an effective and efficient way of learning about the learning process. Right at the heart of the learning difference between humans and AI is scarcity. When people like Elon Musk worry about the machines winning, they are referring to systems that have learned to operate using reinforcement learning (RL) models. Musk was very vocal with his warnings and criticism of dangers of DeepMind's AlphaGo. In response, he established OpenAI to create a safe path to artificial general intelligence (AGI), whose primary focus is on reinforcement learning research. These developments are big deals. Most common AI systems are often programmed with the ability to do one specific task, like detecting objects or generating pictures of cats. There are narrow systems that make use of supervised learning techniques. We can predict the output expected because we know what the right answer looks like. We know that the object it is trying to classify as a dog, or that the system is trying to generate a picture of a cat if it's being trained that way. Humans also have limitations in what they do. Limitations in capacity, limitations in brain power, limitation of time, and etc. The human brain itself is limited in its adaptability. It simply makes the most of the information it receives. It then developed the ability to cultivate rich models of the world. Humans are generally purpose learners. With an efficient learning process, humans can be fast learners, picking things up quickly. AI, on the other hand, has a lot more resources like computational power. It also learns a lot more from the data available than the human brain can comprehend. It has the computational power to process a large amount of data in the shortest time possible. At the same time, the increased complexity of the task presented to the AI results in exponential increase in computational power. Each interface that AI makes relies on efficient algorithms to make connections between different pieces of data. If the algorithms are not efficient enough for the given sets of data, there will be an exponential increase in computational power. It doesn't matter how cheap the computational power we have access to these days is. The last thing we need is an exponential increase. To that end, AI is designed to be a specific purpose learner. It's designed to learn from related and similar data. This will enable AI to effectively process data and make deductions without costing a lot. The learning to learn problem came up when technologists were trying to solve the exponential increase in computing power as AI began to surmise from data with increasing complexity. By preventing the exponential increase in computational power, AI has had to figure out the most efficient learning path to take and remember that path. Once the algorithms determine the learning paths from 4 different types of problems, AI can self-regulate and guide itself dynamically by choosing the learning path, following it, and adjusting it for changes. By knocking that problem out of the park, the next one raises its head: multitasking. The issue of multitasking arose when technologists began to give AI tasks that are related but are not sequential. Questions like, what if independent tasks can be performed simultaneously? What if AI performs certain tasks, knowledge and data can be discovered that will help AI perform other tasks? The need for answers has driven the partially solved problem of learning to learn to another level. To be able to multitask, AI needs to be able to review independent sets of data concurrently. AI needs to be able to relate pieces of data and make connections upon the information processed. As one task is performed, AI needs to remain constantly updated to know which situation to apply the received knowledge to. As the tasks are interrelated, the evaluations will be performed by the entire network. An example of an AI system that has learned learn to perform separate tasks simultaneously is Google's multi-mode. The system imitates the way the brain senses information. It can spot objects and images, offer captions, recognize speech, translate between 4 pairs of languages, and perform grammatical constituency parsing. The system has achieved excellent performance, all while training jointly on several tasks. The neural network is also learning from several domains of data. To be truly adaptive, AI needs to learn to multitask. A type of AI application as adaptive learners is in robotics when the robots learn to perform tasks in dangerous situations rather than humans. An example is a robotic military dog that can adapt to situations rather than follow the strict commands from humans, either at surveillance or capture situations. From Google's multi-model, we know that AI can learn to become general-purpose learners like humans. However, the idea is still largely theoretical, with a ways to go before it becomes real. This is because of 2 reasons: meta-reasoning and meta-learning. Meta-reasoning focuses on the efficient use of cognitive resources, while meta-learning focuses on a human's unique ability to efficiently use limited cognitive resources and limited data to learn. One of the few components of meta-reasoning is strategic thinking. If AI can draw inferences from several types of data, can it also employ efficient cognitive strategies in different situations? Several studies are currently underway to learn the gaps between human cognition and the way AI learns, such as awareness of internal states, the accuracy of memory. In the end, meta-reasoning depends on seeing the big picture and strategic decision making. To make strategic decisions, there are 2 main parts involved: picking from the existing strategies and discovering the list of strategies available based on the situation. These are all areas of study in meta-reasoning. For meta-learning, one of the key components is to bridge the gap by making use of several amounts of data to train models versus making use of limited data to train models. Models have to be adaptive to be able to accurately make decisions based on small sets of information across multiple tasks. This area can be approached in several directions. Some models will define an optimal learning space, like the metric space, where the learning can be the most efficient. There are also models, like few shots meta-learning, that the algorithm learns the way babies learn by mimicking from the minimum amount of facts. There are also several areas of study in meta-learning. Both meta-reasoning and meta-learning are only aspects of AI becoming a generalized learner. To make them more human-like, these 2 areas would have to be put together, along with information from the motor and sensory processing. The truth is, AI still has a ways to go before it becomes more like humans. There is extensive research ongoing to learn more about how humans learn, adapt, and process information. The results derived are then inputted to make an AI more human-like. Some of the hurdles that AI researchers have to climb, including teaching AI how to adapt to new situations, how to multitask, and how to make strategic decisions with limited resources. AI still has a long way to go before it can perform the same functions as humans. There's no question that all that's left is how fast advancements are made in the field. The question many are asking now is the direction of advancements that are currently made. Nobody wants an invasion of the robots, but many really smart people are questioning if the path we're treading is the right one. Several ethical debates are popping up about AI and its many divisions. Artificial general intelligence, AI agents that can learn to do any task, has also come under a lot of scrutiny. It's believed that technology holds the potential to cause great chaos to the world if it's used immorally. The famous theoretical physicist Stephen Hawking revived the debate a while back, pondering if our search for improved artificial intelligence will one day lead to thinking machines that will take over from us. The British scientist raised the thought-provoking question while he was in an interview. The world-famous theoretical physicist has amyotrophic lateral sclerosis, ALS. He makes use of new technology to help him communicate. The technology works by modeling his previous word usage to predict that words he will use next, quite similar to predictive texting available on several smartphones. Professor Hawking mentioned that as time passes, the development of machines might one day surpass us. Once humans develop artificial intelligence, it would take off on its own and redesign itself at an ever-increasing rate. The development of full artificial intelligence could spell the end of the human race, he warned. At times like this, it's important to remember Murphy's Law. Anything that can go wrong will go wrong. As exciting as it may sound to build AI, perhaps we shouldn't. Who knows? There you have it, guys. With the great strides made in AI technology, it seems those Hollywood movies won't be just futuristic movies for much longer. Be sure to give this video a thumbs up for more videos like this. Bye, guys.